Hello, my name is Stefan. I am an engineering graduate. I graduated about 1 year ago, and for the time being, I've been helping students realize their potential in the STEM programs. In this video that I recently made, I will be going over function notation, inverse functions. I'll be showing a real example that I'm sure you're familiar with and many people are familiar with of inverse functions. And if you stick around till the end, I will give hand-picked questions that my students and I believe we've seen on tests before and that seem to be the harder ones. So if you could do those, you're laughing. Anyway, thank you, and I look forward to helping you out. All right, so getting right into it. Give me 1 sec, we'll pull up some OneNote stuff, and let's start. So we have 2 monkeys. One of them is happy with y equals mx plus b, and one of them is not too happy. He gets confused when he sees f of x. He doesn't understand what's the point of it. It's just more confusing. He's having a bit of an existential crisis. He's making mistakes. And hopefully, if he watches this video, he'll be all right. So, first distinction is these are equivalent statements. They mean the exact same thing. All right? They're synonyms. All it is f of x is just a more confusing way of writing what a function's name is. That's what we're going to call it. So, given that, we're going to have some f of x is equal to y equals mx plus b. These are the same things, but they're inherently different. So, given that they're different, what's different about them? Well, this guy is the name of the function. So his name is function f. And the other thing is description of what the function is in terms of. So description of the variables that are present in this function. And so in this equation, we know that m and b are constants, so they don't really vary. And x is the variable, so it's just a description of the variables. So the language that will help any confusion is when you see this guy, you associate the sentence of function f in terms of x, which is the same as saying y. For y, it's implied that x is the variable. You could, however, write y of x. That's equally as correct. It's more precise. That's why people use it. Basically, with precision, when it comes to multivariable equations, it comes back hard if you ever want to take calculus or any university level maths. Function notation is a must. So that leaves the next part of the video, which is what the heck's an inverse function. So you're going to see stuff that look like this, where you have a little -1 exponent in front of that function. And that means inverse, okay? Which is really important to not confuse it with this. Those do not equal the same thing. This is a curveball question that will get thrown at you either in the format of multiple choice or whatnot. So, Stefan, you've explained to me that they're not equal. So what's the guy on the right called? The language for him is called a reciprocal. And this guy is our inverse. So both of them share exponents, but one is kind of embedded on the f and the other is around the whole function. All right, so now that we know the language that's associated with function notation and the basis of what an inverse function is, let's do some examples, because that's really the only way you're ever going to get to learn them. So this is a great question, converting from degrees Fahrenheit to degrees Celsius. So this is the question. What is 0 degrees Fahrenheit in Celsius? And so what we could do is we could just sub in 0 degrees here, right? And solve for everything, right? Begin isolating, move the 32 over, divide by 9/5, and you're going to get Celsius. That's perfectly okay. It's just sometimes you need an inverse function. Say you want to automate this as a computer program. You'd need to develop a function to do it. One that's reusable depending on if you get an input as Fahrenheit or degrees Celsius. It's useful to create that inverse function. So how we're going to do that essentially is figuring out what is the inverse of this guy. And so what we're going to do is we're going to isolate before we sub in anything. So my first step to solving inverse functions is I like to get the function in terms of variable out of there and just sub it in for something easy. So in this case, we'll do f. So f is equal to 9/5c plus 32. Now we're going to do some algebra. So if this is unfamiliar or rusty to you, I would highly recommend freshening up on your algebra. So subtract 32 from both sides. So the plus there in front of the f, he's implied. So these guys will go to 0. We're going to be left, we could rearrange this side for f minus 32. We're going to have 9/5c. And so in order to get rid of the 9/5, because our purpose right now is to isolate for c, algebraically isolate, we're going to divide out 9/5, and we do that to both sides. So this kind of looks funny. Fractions aren't too fun if you're not familiar with them, but if you are, you would know that you can flip them and multiply. So that's exactly what we're going to do. Flip him and multiply by everything. All right, so these guys will cancel out. You're going to be left with c on one side and 5/9 times f minus 32. And so what this guy is, we just developed an equation that we could call c of f. That's a bit messy for my liking. We'll call it c of f. That's what this equation is. And so to go back to our original question of what's 0 degrees Fahrenheit in Celsius, all we would have to do is sub in 0 degrees Fahrenheit in for that. And then we'd get the degrees Celsius. I'm not going to do that, but I encourage you to and see what the answer is. So going to our hard question, same exact process. All right, nothing really changes. It's the exact same thing. So first thing, recognizing they have some function that they named f, and it's in terms of x. We can see that all the variables here are x. All right, and they want the inverse function, not the reciprocal. Okay, so if we were to give them a reciprocal function for this guy, he would look something like this. But that's not what we're asked here. We're asked for the inverse, specifically in terms of x. So let's figure out the inverse. First steps first, we could let our function in terms of x equal y, because that's super easy when we're doing our algebra. And we begin isolating for x. So what we're going to do is multiply both sides by 8x. These will cancel out. You're going to be left with 8xy is equal to 10 minus 3x. And our purpose, again, is to isolate for x. So how we're going to do that is to group our x's. And we do that by adding a plus 3x to both sides. These will go to 0. And you're going to be left with 8xy plus 3x is equal to 10. So at this point, this is another mistake that I see is a weakness in factoring. If that is your weakness, do a few practice problems. It will make your math life a lot easier. So right here, we would be doing a factor by grouping. We have two groups, and what's in common is an x. So essentially what's a factor between the two groups are in X, so we could divide out the factor. And we do that by pulling it in front, just like that. And these are equivalent statements. They mean the same thing. It's just one is manipulated with a divisor out. So we're at a position where now we could truly isolate for X. And so how we're going to do that is dividing both sides by 8y plus 3. These will go to 1. And you're going to be left with X is equal to 10 over 8y plus 3. All right, so we figured out the inverse function. What was the question, though? The question asks us for the inverse function in terms of X. Well, we have an inverse function, but it's in terms of y, right? Y is the variable here. So how do we deal with that? So we have an inverse function, but it's in terms of y. So all we have to do is sub, not x in for x, but x in for y. And we'll have our solution. So we have the inverse function in terms of x is equal to 8x plus 3. And that's our final answer. If you found this video helpful, great. Any questions, leave a comment. If you'd like me to do any videos in the future, let me know. I'm always happy to do that as well. Anyway, happy studying and enjoy your winter break. Take care.